This is my crappy 1950s track house. It looks just like all the houses in this neighborhood. They are small, originally only about 900 square feet. So in an effort to add curb appeal or stand out in some way, people have added on over the years. Some people add on front patios or carports or garages. Or they convert their garage into living space and then add another garage onto the front of their old garage. This guy even installed a putting green. One thing that's really common in my neighborhood is maintenance. These houses are very high maintenance. Welcome to Paul's Passive House. Let's start out this journey by learning about passive house building science. This is a picture of what a prototypical passive house looks like. This is the first passive house ever built. As you can see, they look pretty similar. But passive house isn't just for single-family homes. Passive house is a building efficiency standard where buildings are built to accomplish specific goals. So there are passive house dorms, supermarkets, apartment buildings, government buildings, pools, office buildings, factories, townhomes, event centers, places of worship, fire stations, and, my personal favorite, retrofitting existing buildings to a passive house standard. So as you can see, passive house can work for every building application in every climate. How is this possible? Because it incorporates the most stringent building science standards ever conceived. Building science is a collection of knowledge that incorporates physics, architecture, and human physiology and psychology. Armed with evidence gathered from these disciplines, builders construct the most efficient buildings possible, while providing their inhabitants with the highest quality comfort and health. A passive house must meet the following criteria. Its primary energy demand must not exceed 120 kilowatt hours per square meter of living space per year. This includes a 15 kilowatt hour per square meter allowance for both heating and cooling. And again, that's per year. This energy demand must be met for all living areas while maintaining a specific thermal comfort requirement. The living quarters must not exceed 25 degrees Celsius, that's 77 degrees Fahrenheit, for more than 10% of any given year. To achieve these ultra-low energy usage requirements, passive house building science incorporates the following techniques. An airtight building envelope, represented by the red line in this image. The airtight envelope allows for minimal heat gain or loss due to free-moving air, or convection, between the inside and the outside of the structure. This airtight requirement also allows for highly controlled ventilation, which we will cover shortly. Next, passive house building techniques include a robust and continuous thermal insulation envelope, represented here by the yellow line. By incorporating a continuous and robust thermal barrier, heat loss or gain from conduction is minimized. This also ensures no thermal bridging at connection points. And speaking of thermal bridging, shown here where the structure's joints meet, occurs when heat passes through a solid object like a 2x4 stud or a windowsill. By incorporating details that specifically address thermal bridging at these troublesome connection points, passive house buildings maintain efficiency standards. Which brings me to fenestration, which is just a fun way of saying windows and doors and how they are arranged in a building. Passive house doors and windows incorporate gaskets, insulation, layers of glass, and other details to ensure airtightness and thermal continuity. Finally, heat recovery and energy recovery ventilators are utilized to ensure clean, fresh, and conditioned air enters the house while expelling stale air. Due to a passive house's airtight building envelope, ventilators are needed to provide passive house buildings with a continuous supply of fresh air, virtually eliminating the need to open windows, incorporate air purifiers, and dehumidification. By transferring the heat energy either into or out of the incoming air, passive house buildings stay fresh while maintaining their energy efficiency. Now let's discuss the final piece of the puzzle. My crappy 1950s track house. You see, last year I had some guests over for the holidays, and it was just a disaster. It was cold and dirty, and the furnace kept cycling on and off and on again. It ruined everybody's sleep, kept waking everybody up, and it never seemed to get warm in here. It's so drafty. Well, anyway, I decided at that moment that I was going to do something about it. I decided that I was going to turn this old, crappy 1950s house, my house, into a passive house. But the question remains, where do you start? I mean, most people, when they think of doing a remodel or a retrofit, they think of doors and windows. They get excited about latches and tilt and turn and triple pane and all those fun words. Not me. I get excited about HVAC. I love the idea of having warm, cool, perfectly filtered air, and at a fraction of the price of what I currently pay. But the reality is that in these old houses, it's the walls, the floor, and the ceiling that I have to address. Which means insulation. Which means I have to go into the attic. Now, this isn't my first time working in the attic. When I first moved in, I did some updates. I sealed the lighting, I added insulation, and I installed new ducts. Plus, my furnace is up here, and I've had to service it a couple of times over the years. Now that I'm up here, though, I'm starting to remember just how horrible it was. As you can see, the people that built this house insulated the attic with what looks like shredded tree bark, and it's only about 2 inches deep. Plus, there's lots of debris up here and dangerous wiring. So this is going to suck. Hey, I know. Let's listen to some music.
It don't matter none, it don't matter none. You can call me a nihilist, well I might just be one. But beer and weed are guaranteed to make my motor run. If you don't get high, well I wonder why, 'cause it don't matter none. It don't matter none, yeah, I'll have my fun. You can call me a hedonist, well I might just be one. But beer and weed are all I need to greet the morning sun. And if you don't get high, well I wonder why, 'cause it don't matter none. Chardonnay and Merlot. If you had a bad day, that's a damn fine way to go. But beer and weed, oh yes indeed, they make my motor run. And if you don't get high, well I wonder why, 'cause it don't matter none.
Well, that was fun. As you can see, I'm not built for this type of work. Due to all the debris, I couldn't just vacuum up the old insulation. I had to scoop it out by hand and remove it in small bags. For those of you that are wondering, I tested all of this material for asbestos, and it all came back negative. I highly recommend that if you're considering doing any home improvement, that you first test all the different materials and surfaces for asbestos. And do it before you get started. It's cheap and easy. And it should go without saying that you need to wear a respirator and that you should change out the filtration cartridges in your respirator every 8 hours. Thank you for watching. If you'd like a free energy efficiency consultation, please email me at paulspassivehouse@gmail.com.